Fractions are divided into two categories based on how big they are, that is, based on how large a quantity they represent. Proper fractions are smaller than one whole thing. We can recognize them because their numerator is less than the denominator. So, for example, 1/2, 3/5, 19/20, 1/831. These are all proper fractions. They all have a numerator less than a denominator. They all represent less than one whole thing. An improper fraction is any fraction that is not proper. So they may equal 1, or they may be larger than 1. And this category also includes fractions that represent whole numbers. 5 wholes, for example, would be an improper fraction. Now, it's important to note that even though we use this word improper for them, there is absolutely nothing wrong with an improper fraction. Very often, an improper fraction is exactly what we want. It's not going to collapse under its own weight because it's smaller at the bottom, nothing like that. However, there is an alternative notation that we can use to describe an improper fraction that is not a whole number. And that notation is called mixed number notation. What is mixed number notation? This is an example of a mixed number, 7 3/4. Note the use of the word and. The word and in the name of a number always introduces a fraction part. In a mixed number, we have two parts, a whole number part and a fraction part, which must be proper. What's going on here? Now, what's going on in this notation is actually pretty weird. Usually, especially in algebra, when we write a number next to something, we mean multiply. But that's not the case here. In a mixed number, the whole number part and the fraction part are added. So 7 3/4 means the whole number 7 plus 3/4. This suggests an obvious way to, given a mixed number, rewrite it as an improper fraction. So we would take 7 plus 3/4, make the 7 look like a fraction, write them with a common denominator. It's easy to see that my common denominator is going to be 4. So we get 31/4. That's the easy one. Converting from an improper fraction to a mixed number is a little bit trickier. Given the 31/4, how could we get the 7 3/4 back? And the answer to that is we need to shift our perspective back to understanding fractions as division. Watch what happens when we do that division, 31 divided by 4. We'll say 4 goes into 31 7 times, which uses up 28 things. 3 left over. The quotient is our whole number part, and the remainder is the numerator of our fraction part. So Our whole number part is 7. The numerator of our fraction part is 3. And the denominator doesn't change. Another example, just so we can see one where we don't already know the answer. To write 83/6 as a mixed number, we'll divide 6 into 83. 6 goes into 8 once. 6 goes into 23 3 times, because 3 times 6 is 18. Five left over. So the quotient is my whole number part. The remainder is the numerator of my fraction part. I get that 83/6 is equal to 13 whole things and 5/6. Okay, a couple of notes and cautions with mixed numbers. In a negative mixed number, both parts are negative. So, for example, if I have -5.5, that means -5 plus -0.5. The second one has to do with how we actually perform arithmetic on mixed numbers. The simplest way to perform arithmetic on mixed numbers is to convert to improper fractions, do the arithmetic, and then convert back. It's especially important that multiplying the whole number part and multiplying the fraction part separately does not give the correct product. So for example, if I have 1.5 times 1.5, converting those into improper fractions, I get 3/2 times 3/2, which is 9/4, which is 2 1/4. Totally not 1 1/4, which is what I would get if I multiplied separately. Again, the simplest way to do mixed number arithmetic is to just convert to improper fractions and then convert back.